Hello everyone, this is one of the group in CE1 presenting you the chapter 5 virtual collaborative discussion on the equipment of pipe and duct flow. So firstly, let's look at the schematic diagram of the pipe or duct. So we know that the heat loss from a hot fluid is due to the second law of thermodynamics. Okay, so now let's look if there's a heating section in the control volume, then we can say the work interaction should be considered. Okay, some of the points we have to analyze for the pipe and duct system, which is heat transfer, work, change of kinetic energy, and potential energy. Okay, by deriving energy balance for a steady pipe flow system, since it is in a steady state, then we can say that it is equal to 0 because there's no change in all points in the interval of time. So we can say E in equals to E out. By expanding it, arranging, then we will get the energy, the final formula for energy balance. Now, about the function of equipment, you know that pipes and ducts are used to transfer fluid from one device to another. For the startup and shutdown periods, which are transient process are excluded. What is a transient process is when a process variable or variable that have been changed in the system has not yet reached a steady state. These are some of the examples for the piping system for pipe and duct. Water distribution piping system, home plumbing system, swimming pool plumbing system, and also fire sprinkler system. Okay, now let's look at the question 12, which is the tutorial question 12. Steam enters at a long horizontal pipe with an inlet diameter of 16 cm at 2 megapascal and 300 Celsius with a velocity of 2.5 meter per second. The exit conditions are 1.8 megapascal and 250 Celsius, and the diameter is 14 centimeter. So now the information is given a lot, so we can make assumption first. The kinetic and potential energy are negligible, and the steady flow is inside the pipe, and there's no work interaction because there's no devices. So by using table F5, which is the saturation water pressure table, then we can find the inlet steam and outlet steam is in superheated vapor using the pressure. Now we can find the table S6 with the inlet information, then we can find the specific volume and also the enthalpy. By having these two information, then we can these two and also the velocity, then we can find the mass flow rate. So the analysis is obviously the pipe is the system. Now let's solve the energy balance. So in the previous slide, we know that E in equals to E out. Expanding it, no Q in because question doesn't mention about Q in. There's no work, no devices, no elevation. Can be cancelled. KEPE equals to 0, negligible, and then we will get Q out of this formula. So from the outlet stream information, we can get it from using table S6, which is superheated water table. Then we get the enthalpy for the outlet stream. Then by substituting inside the Q out formula, which is this one, then we will get the Q out, which is the heat transfer in kilojoule per second. That's it from our question, and thank you everyone for listening.